Good morning children. Today we are going to start organic chemistry. The first chapter in organic chemistry, that is haloalkanes and haloarenes. That means in this chapter we are going to deal about halogen compounds. Halogen, only halogen coming as functional group. So first we are going to study about the classification of haloalkanes and haloarenes. So before we start the classification of haloalkanes and haloarenes, first we will see what is meant by haloalkanes and haloarenes. Haloalkanes are also known as alkyl halides because alkyl halide is actually the common name. And haloalkane is the IUPAC name. So haloalkane is the IUPAC name and alkyl halide is the common name. Now haloalkanes are generally represented as Rx, where we know that R is the general representation of any alkyl group and X can be any halogen atom like fluorine, chlorine, bromine or iodine. For example, CH3Cl, CH3CH2Br, all these are examples of alkyl halides because halogen is directly attached to an alkyl group. Here it is methyl group and here it is ethyl group. The alkyl groups, all the alkyl groups and the functional groups already we have learned in class 11. Now, the next type is haloarenes. We know that already in class 11 we studied about arenes. Arenes means aromatic compounds are known as arenes. So haloarenes means halogen containing aromatic compounds. So for us there are so many there are so many aromatic compounds are there, but for us aromatic means containing benzene ring. So here haloarenes means halogen atom attached to benzene ring. Now, they are also known as haloarene is actually the IUPAC name. They are also known as aryl halides. So, as we know, aryl halide is the common name or simply we can call it as aromatic halides. So, here in aryl halides, X will be directly attached to a benzene ring and this benzene ring or an aryl ring can be generally represented as AR. So, aryl halides can also be represented as ARX. Or we know that the molecular formula, if we write the molecular formula, this ring we can represent it as C6H5X. So this is about the haloalkanes and haloarenes. So remember, haloalkanes means alkyl halides where halogen will be present or halogen will be attached to an alkyl group. But in the case of aryl halides, halogen will be attached to a benzene ring or any aromatic ring. Next, we will see the classification of halogen compounds. Classification of haloalkanes and haloarenes. First classification is actually based on the number of halogen atoms present. So on the basis of the number of halogen atoms present, the first classification is monohaloalkane. Monohaloalkane means in a haloalkane if there is only one halogen present. For example, CH3Br. So here only one bromine or one halogen is present and there is an alkyl group. So it is a haloalkane where only one halogen atom is present. So it is a monohaloalkane. Or the next classification is monohaloarenes also there. That means benzene ring containing one halogen atom. So if there is only one halogen atom present, there is monohaloalkanes and monohaloarenes. Now the second classification is if there is two halogen atoms present, that is dihaloalkanes and dihaloarenes. For example, CH2Cl, CH2Cl. Here two chlorine atoms are present, so it is a dihaloalkane. Similarly, in a benzene ring, if two halogen atoms are present, it will be called as dihaloarene. Now the third classification is if there is three halogen atoms present, it will be called as trihaloalkane or trihaloarene. For example, CH2Cl, CHCl, CH2Cl. Here 3 chlorine atoms are present, so it is a trihaloalkane. And here in benzene ring 3 chlorine atoms or 3 halogen atoms are present, so it is a trihaloarene. So this is about the classification of haloalkanes and haloarenes based on the number of halogen atoms present. Now, the classification of monohalogen compounds only. Monohalogen compounds means containing only one halogen atom only. That is the next thing we are going to learn. They are classified. Actually, the monohalogen compounds are classified based on the hybridization of carbon. The hybridization of which carbon? The carbon to which the halogen atom is attached. So, based on the hybridization of carbon to which this halogen atom is attached, the monohalogen compounds are classified. So, first one is the compounds in which the halogen atom is attached to an sp3 hybridized carbon. So, here halogen will be attached to an sp3 hybridized carbon. Here we have the first one is haloalkanes or alkyl halides, and we already we have seen that alkyl halides general representation is Rx. So, here we know that alkane general formula. What is the general formula of alkane? CnH2n plus 2. So, when one halogen atom is present, what happens? How the halogen is coming here? By replacing one hydrogen from here. So, the formula will become CnH2n plus 2. Instead of H2n plus 2, it will become H2n plus 1 X, because one hydrogen is replaced by X. So, here in haloalkanes and alkyl halides, here they are again classified as primary, secondary and tertiary halides. And this classification as primary, secondary, tertiary already we have learnt in class 11. What is meant by a primary halide? Primary halide means X will be attached to the X attached carbon atom will be attached to only one other carbon atom. So, let us see the example of CH3CH2Br. Here it is a primary bromide. Here the functional group is bromine, so we can call it as a bromide. It is a primary bromide or a primary halogen. So, in order to classify a halogen as primary, secondary or tertiary, we have to see only the X attached carbon. So, here bromine attached carbon is this. So, if the X attached carbon, if it is attached to one other carbon, so this carbon is attached to only one other carbon, so it is a primary carbon. Or very easy to identify, if the halogen attached carbon, if it is CH2 with 2 replaceable hydrogen atoms, it will be primary. Okay, so if the X attached carbon atom is CH2 with 2 replaceable hydrogen atoms, if it is CH2AX, it will be primary. Okay, now the next classification is secondary halide. Secondary halide means the X attached carbon that will be attached to 2 other carbon atoms. See the example. A secondary halide example is CH3, CHBr. So, how we can check whether it is a primary, secondary or tertiary halide? Look at the X attached carbon. So, here the X is bromine, the bromine attached carbon is this, and this X attached carbon will be attached to 2 other carbon atoms. So, here it is attached to 2 methyl groups. So, it is attached to 2 other carbon atoms, so it is a secondary carbon. Okay, so now, here also very easily we can identify the secondary halides, that is, if the X attached carbon, if it is CHX, it is secondary. That means X attached carbon, if it is CH, it will be secondary. Now, in tertiary halides, tertiary halide means the X attached carbon atom that will be attached to 3 other carbon atoms. So here, look at this example, which is the X attached carbon atom here. Here the X is bromine and the bromine attached carbon is this, and that carbon is attached to 3 other carbon atoms. So it is a tertiary halide. So in order to classify a halide as primary, secondary and tertiary, we have to see only the X attached carbon atoms. So if the X attached carbon atom is CH2, it will be primary. If it is CH, it will be secondary. If it is C only, it will be tertiary. Very easy to identify. Primary means X attached carbon will be always CH2 with 2 replaceable hydrogen atoms. If it is secondary, the X attached carbon will be CH, and if it is tertiary, the X attached carbon will be C only without any replaceable hydrogen atoms. So this is about the classification as primary, secondary and tertiary halides. Now the next classification is, so remember, now we are classifying the compounds based on the hybridization, isn't it? So the next classification is, that means where the X attached carbon is sp3 hybridized, isn't it? So for second type is allylic halides. Allylic means halogen will be attached to an sp3 hybridized carbon, but on adjacent position there will be a carbon-carbon double bond. Once again, X will be attached to an sp3 hybridized carbon next to a carbon-carbon double bond. That means X will be attached to an sp3 hybridized carbon, and on adjacent position there will be a carbon-carbon double bond. Look at the first example here. Here the X is attached to an sp3 hybridized carbon because surrounding there is no pi bonds present. Now adjacent to that there is a carbon-carbon double bond. So that is an allylic halide. So here also X is attached to an sp3 hybridized carbon, and on adjacent position there is a carbon-carbon double bond. Such halides are known as allylic halides. Next one is benzylic halides. Benzylic halides means here also X is attached to an sp3 hybridized carbon, but on adjacent position there will be an aromatic ring, or we can call it as benzene ring. Clear? So here in benzylic halides, X will be attached to an sp3 hybridized carbon. On adjacent position, not double bond, instead of that there will be a benzene ring or aromatic ring. In allylic halides, adjacent position double bond present in a chain, here or ring. So here on adjacent position benzene ring will be present. Now look at this example. This is the X attached, this is the functional group, that is chlorine or halogen. Halogen is attached to an sp3 hybridized carbon, and on adjacent position there is a benzene ring. So we can call it as a benzylic halide, but here X is attached to CH2. So we can call it as a primary benzylic halide. As I told you, very easy to identify primary, secondary and tertiary. If the X attached carbon is CH2 primary, if it is CH secondary, if there is no hydrogen on that carbon, if it is only C, it is tertiary. So here it is a benzylic halide. Now in the second one also, X is attached to an sp3 hybridized carbon, and on adjacent position there is a benzene ring or aromatic ring present. So it is a benzylic halide. At the same time, it is a secondary benzylic halide because the X attached carbon atom is CH. So it is a secondary benzylic halide. Now the third case also, X is attached to an sp3 hybridized carbon, and on adjacent position there is a benzene ring or an aromatic ring present. So it is a benzylic halide. At the same time, it is C only without any replaceable hydrogen. That means it is a tertiary halide. So it is a tertiary, what type of halide it is? It is a tertiary benzylic halide. So this is about the classification of compounds in which X attached to sp3 hybridized carbons. They can be primary, secondary, tertiary, then allylic and benzylic. Now, the compounds in which X is attached to sp2 hybridized carbons. First one is vinylic halide. So here X will be attached to an sp2 hybridized carbon of carbon-carbon double bond. For example, here X is attached to, as we know, this is a sigma, pi, sigma. So here X is attached to, what is the hybridization of this carbon? Surrounded by 1 pi means it is sp2. So here X is attached to an sp2 hybridized carbon of carbon-carbon double bond. Clear? That means X is directly attached to a double bonded carbon, and such compounds are known as vinylic halides. And then the last classification is aryl halides. Aryl halides means the halogen atom will be attached to an sp2 hybridized carbon atom of an aromatic ring or benzene ring, or simply what we can say is X will be directly attached to an aromatic ring or benzene ring. Okay, so here the X is attached to this carbon and it is sp2 hybridized. Here also X is attached to this carbon, it is also sp2 hybridized. And so halogen is directly attached to, or halogen is attached to an sp2 hybridized carbon atom of benzene ring or of aromatic ring. Such compounds are known as aryl halides. Okay, halogen directly attached to benzene ring means it is aryl halides, or in between the halogen and in between the halogen and benzene ring, if a carbon atom is present, such compounds are known as benzylic halides. So this is about the classification of haloalkanes and haloarenes.